folks. I'm not nervous at all. So I'm Olga, obviously. You've heard it maybe like 4 times already. I am from REA. I do some techie stuff. And today I'm going to talk about testing Ruby microservices. Full disclosure, this is our experiences in testing Ruby microservices in one line of business within the REA. It's not applicable maybe necessarily for all of the people, but nevertheless, our experiences, so our war stories pretty much in terms of the testing. This presentation is going to be covering mostly behavior testing. I'm not going to cover load testing or security testing, so keep this in mind. It's mostly like unit testing, integration testing, stuff like that. And the combination and testing strategy around that. So, a little bit about where I work. So I work in a department called the Money. By far the dopest name to work for. Seriously, who can say that I work for the money? As Simon and Lizzie said, we're hiring literally everybody. Delivery leads, QAs, tech leads, systems engineers, developers. So please come and talk to Simon right there and Lizzie right there. About the money, so the money itself as a line of business covers everything to do with quote to cash process. Given the name, obviously it's all about how REA makes the money. Anything to do with customer engagement, anything to do with contractual agreement, with quote to cash process, with accounting. That's what we cover for the entire business. We don't have just realestate.com.au. We have real commercial, we have flatmates, there are so many businesses under it, there is also Asia businesses, so it's not just one thing, it's actually supporting the entire business to make money. So keeping this in mind, this is what our architecture looks like at the moment. Maybe a couple of services are missing, so it's actually quite complex. We follow the concept of micro-ish services. You don't need to understand what's happening. The concept is just to show that it's big and there are lots of moving parts. It's mostly backend. There are some UI applications here and there, some key databases that we need to consider. There is some legacy floating around, some Ruby microservices here and there. But essentially what I wanted to convey is it's a lot of moving parts. How do you test all of those and make sure that they actually do the right thing? And considering that this is where we make the money, actually making money, we better make sure that it works because otherwise we lose revenue. So how do you test it reliably? With so many moving parts, with so many problems or little niggly issues. And full disclosure here, I'm going to be talking about the testing for, we mostly have Ruby microservices, so I'm going to be talking about mostly testing our Ruby, I'm a bit nervous, so sorry. Mostly testing our Ruby applications. We have some legacy stuff in .NET, which is not going to be covering or other languages, but that's what it's going to cover. And to begin with, to kind of go through all of those ideas, I want to give a quick run through of what kind of test approaches am I going to be talking about in this particular talk. To begin with is unit testing. I don't need to go into too much details of what it is about. I'm hopefully everybody fairly aware of what it is. It's testing one small piece of code in neat, unisolated way. The pros of this particular approach is it's great to test all of the scenarios. Great to test all of the predicted unpredictables. So the reason why it's predicted unpredictables, it's only about the developers coming up with all of the use cases and edge cases which you're creating unit tests for. Obviously, you might not come up with all of the scenarios of predicted unpredictables. It's great to test the business value of every single line of code. And I'm a true believer that every line of code that you write delivers business value. And they're pretty fast. Like, compared to other types of testing, they're actually quite light fast. The cons of this particular type of testing is that, especially in Ruby, some tests are, well, that's actually applicable across all of the languages. Some tests are written for the sake of writing tests. They don't actually test any functionality. So you need to be aware of whether you're doing the right thing when you're writing your unit test or not. The other con is that in Ruby unit testing, mocking, especially given it's a dynamically typed language, can be sometimes too mocky, which means that you're not actually testing the contract between your method calls, that you're passing in the right parameters, you're not passing in the right values, you're testing that it's just been called. And that creates a problem that even though all of your unit tests might pass, when your application is actually running, it throws runtime exceptions, well, because you mocked too much, you haven't actually validated that the entire flow works together. That's some of the experiences we had. The second type of testing is unit testing that I'm going to be talking about, but what I would like to distinguish in this particular scenario is the fact that it's in-app integration testing using unit tests. So what do I mean by that is that you test everything from sending the request to the application, to your microservice. Well, I don't believe in microservices. Everybody calls it microservices, but they're actually not micro. But anyway, so you send a request to your service, and you make sure that the entire flow works up until the lowest point, whether you're either calling the outside service, the next service downstream, or call your database. So you make sure that when this mocking is too mocky, you're actually not throwing the runtime exceptions when you're doing the when you're running your application. The cons of this is you are you know that your application works end to end because, well, you have checked it out. The other plus side is the fact that you test that all of the scenarios that you care about perform correctly and return the right outputs within your the concept of your microservice. The cons are that they can be slower, especially depending on how you mock or how much you write, whether you have a lot of I/O operations or not, whether you, I don't know, Docker container in which you're running, the thing is customized for it or optimized, whatever solution there could be a bit slower, essentially. I'm coming up with like random scenarios that probably don't make any sense, but whatever. Essentially, the other problem is that you need to determine at which point to mock. So if you're testing within your application, the end-to-end flow, if you're having your I/O operations into the database, or if you're having your API calls to the downstream services, or if you have the right operations into the files and whatnot, you need to mock at some level. And this level sometimes is hard to determine. And it's the scenario of this would be, we have a service that does reconciliation that between the two other services, the databases within the two other services. This is for some of our compliances, so it's a legal requirement to do so. And essentially it needs to connect to two databases that they don't own. In this particular case, you would need to mock out the database connections and you mock out the SQL queries if you test at the lowest level, which can be tricky, especially if you're doing the end-to-end test and you try to get them all together. So you need to kind of decide what's your poison and which level is appropriate for you so that you don't waste too much money, too much time, which is wasting too much money. Actually, if you'll think about it, developers are quite expensive on it. And another case to think about in this in-app application testing is what should you test in those? Should you test all of the scenarios? Should you test all of the edge cases? Should you test your errors or should you test your happy path only? And the answer could be completely different based on whom you're talking to or based on what your requirements are or based on what your application is like. So for example, if you deal with the money, you probably want to make sure that everything works fine, even if you have errors. But if you don't have a critical service, maybe it would be different. But sometimes it's kind of hard to determine when you're looking at it. The next pieces are kind of working through, this is about testing within the application. So what about testing between the applications, between the services? We can consider the full-blown integration tests. So what I mean by that is that you have a test that is running throughout the entire platform on the actual test environment, making sure that it goes through all of the relative services, ensures that the use cases are working correctly. Some of those tests could be also known as synthetic transactions, and I'm going to be referring to that in the future. But this is pretty much ensuring that everything runs within the setup environment in whatever environment scenario that you want. The pros of this, you really bloody know that your architecture works. Because, well, it's running on the freaking services, runtime with almost if you do it right, almost close to real life data. Or sometimes you run it in productions, which we do actually. It runs on the freaking real data and make sure that everything is patched together amazingly correctly. The con of this particular approach is it's super expensive. Imagine you need to maintain your entire environment to run the integration tests. You can have them running on your test environment where you deploy and do your QA, but then the bottom line is if you do your QA, that implies that QA can fail, which means that implies that your integration test can fail at any time. Is it really what you like? Because it adds the level of unreliability and they become really brittle. Anytime the data changes, they break. Every time the test environment changes, like tokens get cycled, the database passwords get cycled, the data gets updated because, well, you needed it for a specific test, it breaks. So does it really bring so much value, being especially expensive from the runtime perspective, but also expensive from the maintenance perspective? Also, it's kind of opens up the question, when should you, because it's so brittle, when should you test it? Should you test it every build? Should you test it on the schedule? Should you test it in production and test? It's kind of always up for grabs. And it's hard to identify the boundaries, or what do you have to test? They're slow. So you need to really consider of what things that are important to you. They produce a shit ton of data. You really need to consider is that the thing that you want to do? So the boundaries become really difficult to understand. The next thing is, as opposed to the integration testing, thanks to Beth Scurry, who actually was at REA back then and experienced the entire integration testing problem, so came up with the idea of pack test, contract testing. Contract testing is essentially making sure that the contract or the interactions between the two applications are correct, according to the expectations. The main thing for the contract testing is actually packed. I hope all of you have heard of it or have an idea what it is. It's essentially if you ensure that HTTP request that you're making to the downstream service returns the right responses, and the downstream service can pretty much handle this HTTP request in the way that it's being made. In a nutshell, it's way more abstract than that, but let's think about this way. The process of this is they're fucking fast. I shouldn't have sworn. Sorry. They're really, really fast. They, compared especially to the integration test, validates that the right two applications can talk to each other. Great. There is no need to have the entire integration environment set up, so it's fairly cheap. The only thing that you need is a plugged broker, but it's fairly easy to set up, and it's not that expensive to run. So pretty neat, right? And they're pretty reliable when defined correctly. This when and if defined correctly is a big if. And the reason why I'm saying this is because some of the cons of the pack test is that the packed altogether, or the contract testing altogether, is a concept that is fairly abstract, which makes it difficult to understand, especially when you have the whole lot of newbies that are coming in who not necessarily working in microservices architecture, who might have not been exposed to pack before. So the concept is quite hard to wrap your head around. And REA has, the money came through actually quite a bit of the hiring spree. So we had quite a few newbies. Getting the concept coming across and landing with people took actually quite a bit of time, which meant there was a lot of failure scenarios and a lot of issues during this process. The sometimes assertions with packed are too vague or too specific. So what I mean by that, too vague, is it doesn't actually validate what you really care about. It just kind of validates, oh yeah, it returns a thing that kind of looks like this, but you might care about the minute details. Or too specific is when people go in and try to evaluate too many scenarios around pack testing, or not use it for the purposes that it's been fit in terms of understanding the contract between the two microservices. As I mentioned, the concept of packed or contract testing is distributed and hard to understand and pick up, especially for newbies. And the problem with this, if you have an established architecture or microservices, you don't actually change your packed setup all that often, which means that for all of those newbies, they pretty much need to relearn it every month or so whenever you're updating the API responses or whatever. Well, depending on how often the application changes. So they keep relearning the same concepts because they pretty much forget by the time they get there. Can you blame them though? You have to learn so much altogether, and there is this new concept that you kind of keep relearning. So given these varieties of test scenarios, how do we implement these tests in the money? So how we can combine them in the testing strategy throughout the money as a line of business life cycle? And the most importantly, why do we combine them in specific scenarios? So long time ago, in the good old days, before there was the money is actually about 3 or 4 years old. What we did is we actually started with an integration test, like full-blown integration test with an integration test environment set up. We had a name for this environment. It was Gandalf. Not because it's old, because we thought it was cool, but then it became old, so it became even more relevant. So thank you, Lizzie, for that. Maintaining the Gandalf environment was really expensive, especially considering that every single microservice that we deployed at the time was to the EC2 service. The clustering did not exist at the time. It was also not clear of who owned, who was using Gandalf outside of the line of business, because people just hooked up to it and started running unit tests against us. We have the platform that provides support for other lines of businesses within REA, because we are all about how the REA makes money, so we need to provide services for that. And it was just really expensive and tedious to run. On top of it, in the applications themselves, we had unit tests with a whole lot of mocks. They were not particularly great. We didn't have many Ruby devs who were writing Ruby services. So mocks were not fully understood at the time. And then the money has formed. And the first thing that we decided is, when we're looking at our testing architecture or testing strategy, we thought Gandalf is too expensive with so many things to run. And it's like, screw that, seriously, the AWS costs alone are just ridiculous. So Gandalf should go. Packed on the new thing. Thanks, Beth. Woohoo! So what that means is we've removed our end-to-end test. We still have the unit test with a whole lot of net-grade mocks, and they're not particularly amazing. And we had the pack tests that were running separately. And what I mean by running separately is we were treating them at unit tests. We did not integrate unit tests and the pack tests together. So they were just kind of two separate entities. Amazing thing, it was super fast, no integration test environment to maintain. Kind of great, did enjoy ourselves. But then we noticed that it was not fully reliable, especially considering that we deal with the money. So passing tests did not really mean that we're passing functionality because, well, we don't have the integration environment anymore to make sure that it's all running properly. As I mentioned, packed was confusing and forgotten by people, so there were lots of problems. And we kind of looked at it and said, we can do better. Surely we can do better. So we moved on to the different approach. We decided to add this in-app integration test, which is a unit test that exercises the entire application to make sure that all of the mocks are not too mocky. We started doing this by introducing them only for happy paths for critical endpoints only. We still had the unit tests that are hanging around with not so great mocks and the pack tests that are running around separately. So it was great for a while. Everything was peachy, we were picking up bugs, everything was amazing. But then we didn't really quite figure out what this mocking should be on the outside boundary of the services in this particular case, so some of the things were slipping through. And we still had problems because we had only unit tests for, or integration tests for the entire application flow that some of our mocks are not too tight, so we didn't pick up all of the problems. So we turned around and was like, surely we can do better. So we went around and said, okay, approach number 3, we have these pacts. Keep in mind, nobody actually knows what pact was supposed to be used for, so not many Ruby devs per se. It's like, we can totally use them for our end-to-end tests. Incorporate them into our flow for the in-app integration test, and it's going to be great. We're going to be awesome. We know that we're mocking at the right level. We know everything is going to be peachy. We'll write to the databases if we need to write to the database. It's going to be amazing. On top of it, we thought, okay, so we have critical systems. How about running integration tests throughout those critical systems? How about adding the synthetic transactions that are running through the application in a test environment, in a production environment? It's going to be amazing. We run this integration test as part of the build. We run this integration test regularly every hour in production and in test. Surely no problems is going to happen. So problem number 1, packed, integrated with end-to-end test was not built for that. When you need to test so many scenarios, especially if you are testing some of the scenarios, it becomes so painful. It's just not designed for it. You should never use it for these purposes because you can never simulate sending the same request. Well, you can simulate. We tried, seriously. We really tried. Send the same request to the same downstream application with different parameters and expect slightly different responses. Really bloody painful impact, which is what we wanted to do for integration tests. Yay! The synthetic transactions, also great idea, right? Amazing idea. Well, we come back to the problem that we were running the synthetic transaction in test for our test environment where we were doing QA as well, so it wasn't stable all the time. Our builds were failing, it was producing shit ton of crappy data. So, and we actually named the synthetic transactions very, very nicely. We called it Cynthia. But everybody kind of learned to hate Cynthia over time, so was not particularly amazing. So we looked around and was like, we can do better. Surely we can do better. So approach number 4, we have the end-to-end test for all of the critical endpoints. For some of them, we handle also the error cases and edge cases if we care so. We have unit tests, which we tied in together with Rubacop config. So we made, and some of the agreements on the spec formats that we follow, like better specs. Great. Mocking only happens at our integration test layer. We split out pacts from integration tests because, well, we learned our lesson. And running synthetic transaction for major use cases, but not as part of the builds, and only twice a day in test and twice a day in production to make sure that we haven't fucked up royally. That's about it. But we're still not happy. There are still problems. There are still things that are slipping through. We're still humans. We still make mistakes. And we're still, like, whom am I kidding? We're still figuring it out. So here are the things, some of the things that still bugs us around our testing setup and our issues, like with the entire strategy. Clean and reusable pack test setup. The amount of boilerplate you need to write to set up the pack test, especially if you're doing the pack test for the specific APIs, it's just ridiculous. And what happens when you have the pack tests from multiple applications to the same microservice? Just like you duplicating the entire thing, but kind of not duplicating, but kind of duplicating. It's just major problem. So there is no necessarily standard to follow that would work for us per se in this particular environment. And we have not yet nailed our boundaries of what is the right thing to test and what is not right thing to test when we're talking about the pack tests. Should we even test error cases? I don't know. We haven't figured it out. If you have a better idea, please come talk to me. Another thing is Rubacop. Does it hinder a help test? Rubacop is amazing. Helps a lot. So we went around our apps and we adjusted our Rubacop config. We used all of the default stuff. We're including Rubacop spec in this. It's like everything is peachy until you need to test the fact that you're making the same call to the same method twice in order with different parameters. Then Rubacop starts throwing exceptions. Yeah, you can escape them. That's fine. It's not really a big deal. But then you kind of start questioning yourself as like, should I be doing this? Maybe it's not a good practice. It kind of has 2 expectations in the same test, 3 expectations in the test. Not great, right? Not great. So it's kind of brings up a lot of questions of what should be the rules like, what are the preferences of each of the developer, opens up a lot of unknowns pretty much around it. The third one is agreements on best practices. So once you agree, it's golden. You have the team that is stable, you agree on best practices, great, right? What happens when new people come in? Especially what happens when quite a bit of new people come in? What happens when new people come in when you have a giant bloody combination of microservices? They already need to learn a new domain. They already need to learn all of those microservices, how they fit together. The last thing that you want them to do is actually to look at all of the beta specs, especially if they don't know Ruby, especially if they haven't followed it, and teach them also how what our standards are like. Yes, it sounds like a good idea, but it's huge overload, and at least we noticed that it's huge overload for us. We do pairing quite a bit, and that helps quite a bit, but at the same time, when somebody tells you to do something, when you don't really believe in it, it's really, really hard sell. So, or they don't really follow it because like you've been told, you haven't believed in it. At least that's my experience. So it kind of causes problems, which brings me to the next point. It would be amazing if all of your application looks the same, but I just went through 4 approaches that we followed to do the testing. So how do you migrate from one strategy to another? You know, you cannot turn around to business and say, we know we want to do, we want to do the new test strategy. It's all great. It's going to reduce the bugs brilliantly. We need like kind of like a month and a half to rewrite all of the specs, just for all of the developers to work on it. Great, right? Can you give us this time? Hell no. So you're pretty much migrating them as you go with the new features that are coming in, with the new functionalities that are coming in, because, well, realistically speaking, nobody's going to give you time to sit around and rewrite tests. So, which comes back to the previous point, you have we haven't nailed it how to do this yet. Essentially what we've been doing is we've been migrating it as we're touching the specs. But then it comes back to the case of what if you have new people who are working on them and they're looking at the previous tests and they happen to be in the old format, so they copy the old format. They don't know that it's wrong. They don't know that it's better, you have new standards. They haven't been aware of all of this stuff. So it's kind of self-perpetuating problem that keeps building up that we haven't figured out yet. If you have, come and talk to me. Another thing is code coverage. So code coverage sometimes can be a hindrance because some people just ensure that code coverage is there just for the sake of getting the number. So the tests are not actually testing the right thing. This is more of a rant, not really much of a thing. Just write the tests that do the thing. Write the tests that do the business value, not some bullshit crap. The other thing is to write to the DB or not to write to the DB. So whenever you're doing your test, should you write to the database? Should you mock it out? I don't know. Figure it out for yourself. Maybe it's like giant writes. Maybe it's not giant writes. That means that you kind of have the database that you need to spin up every single time you're spinning up this test environment, which we spin up in like a separate Docker container, which connect together anyway. So that's additional maintenance. So it's kind of, is it the right thing for you to do so? And the database write IO, even though Ruby tests are usually on a smaller services are super bloody fast. I had this scenario where I was working on an application, one of the servers, and our specs were taking like 4 or 5 minutes. And I'm just sitting there, come on, 4 or 5 minutes, what the hell? It's like, this is ridiculous. If I'm talking to a Java developer, 4 or 5 minutes, what are you talking about? Our tech lead at the time turned around, it's like, you spoiled brat, seriously. But we are kind of spoiled brats. So 1 minute test for the microservice is perfect. So you kind of make a trade-off. If you're doing a lot of I/O operations to your database, that might slow down your tests. And there are a whole lot of other stuff that bugs us, other stuff that are related to our business domain only, the technology domain only, the application setup, the the architectural setup, and all of it could be different based on what you are doing in your environments. For example, for us, synthetic transaction is actually one of them. It's like, what value does it bring, which is how much hindrance does it take, because it creates a shit ton of data in the production. Is it really worth it? Is it really not worth it? Right now, we're kind of running with it, but I don't know. I'm not sold. But yeah, how often? What? So these are just my experiences, and this is what I've observed while I was working in the money. And you obviously have different experiences. You obviously have different approaches. You obviously experience different problems. And I'd really, really like to hear them. Unfortunately, not tonight, because I'm a dumbass who forgot that tonight is my wedding anniversary. So I committed to this particular talk, so I'm going to dash out. But you can talk to me on LinkedIn, on Twitter. I'm more than happy to have a chat and hear all of your experiences. On that note, thank you so much for your attention. REA is hiring. And thank you. Yep.